Copper-clad aluminum, or CCA, wire is not permitted for new electrical installations in the United States. It is important to understand the issues associated with this type of wiring, especially in older homes. While some sources suggest that existing CCA wiring is generally considered safe, several factors can contribute to its failure over time. The copper cladding on CCA wire is very thin, approximately 0.25 inches thick. This thin layer of copper is intended to provide better conductivity and connection properties compared to bare aluminum wire. However, over time, oxidation can occur beneath this copper cladding. This oxidation is a significant concern because it can lead to wire failure. When the oxidation process occurs on a CCA grounding wire, it can compromise the grounding path. This means that a grounded object may no longer have a reliable connection back to the electrical system's ground. A proper grounding path is essential for safety, as it provides a low impedance route for fault current flow, allowing overcurrent protection devices like circuit breakers to trip and clear the fault. Based on observations, oxidation is more likely to occur when the wire is subjected to flexing or movement. This suggests that grounding wires installed inside conduit, where they are protected from physical stress, might be less susceptible to this problem. Conversely, CCA wires located in areas where they experience frequent movement, such as door jambs or behind light switches, are more prone to failure. These locations should be carefully inspected for signs of degradation. Load testing of CCA wires has revealed failures in locations where movement is present. These failures underscore the importance of considering the physical environment when evaluating the safety of CCA wiring. Because CCA wire is no longer manufactured in the United States, the existing installations are aging. Most, if not all, CCA wire was produced before 1973, meaning these wires are decades old, increasing the likelihood of issues related to oxidation and physical wear. Given the potential hazards associated with CCA wiring, it is crucial to have a qualified electrician inspect the electrical system of any older home that may contain this type of wiring. The electrician can assess the condition of the wiring, identify potential problem areas, and recommend appropriate measures to ensure safety. These measures might include replacing the CCA wiring with copper wiring or installing additional grounding conductors to supplement the existing grounding system. When evaluating older electrical systems, it is essential to consider several factors to ensure safety and compliance with current electrical codes. Firstly, inspect all accessible wiring for signs of damage, corrosion, or improper connections. Pay close attention to areas where wires are exposed or subject to physical stress, such as near outlets, switches, and light fixtures. Secondly, check the ampacity of the existing wiring and ensure that it is appropriate for the circuit load. Overloading circuits can lead to overheating and potential fire hazards. The National Electrical Code, or NEC, provides guidelines for determining the appropriate wire size for various circuit loads. Thirdly, verify the integrity of the grounding system. Ensure that all grounding connections are secure and that the grounding electrode system is properly installed and maintained. A properly functioning grounding system is essential for protecting against electrical shock and preventing equipment damage. Fourthly, examine the overcurrent protection devices, such as circuit breakers and fuses, to ensure that they are properly sized and functioning correctly. Overcurrent protection devices should trip or blow in the event of a fault, preventing excessive current flow that could cause a fire. Fifthly, test all ground fault circuit interrupters, or GFCIs, to ensure that they are functioning properly. GFCIs are designed to protect against electrical shock by detecting ground faults and quickly interrupting the circuit. They are commonly required in wet locations, such as bathrooms, kitchens, and outdoor areas. Sixthly, assess the overall condition of the electrical panel. Look for signs of corrosion, loose connections, or damaged components. The electrical panel should be clean, dry, and free from obstructions. Seventhly, check the polarity of all receptacles to ensure that they are properly wired. Incorrect polarity can create a shock hazard. A simple receptacle tester can be used to verify polarity. Eighthly, identify any non-code compliant wiring practices or modifications. Older homes may have wiring that does not meet current code requirements. It is important to correct any deficiencies to ensure safety and compliance. Ninthly, evaluate the lighting system. Ensure that all light fixtures are properly installed and that the wiring is in good condition. Consider upgrading to energy-efficient LED lighting to reduce energy consumption and improve safety. Tenthly, assess the surge protection needs. Surge protection devices can protect sensitive electronic equipment from damage caused by voltage surges. Consider installing a whole-house surge protector to protect the entire electrical system. When addressing electrical issues in older homes, it is essential to prioritize safety and compliance with current electrical codes. Consult with a qualified electrician to perform a thorough inspection and recommend appropriate solutions. Always obtain the necessary permits before making any electrical modifications or repairs. Copper-clad aluminum wire presents specific challenges due to its composition and aging characteristics. Understanding these challenges and implementing appropriate inspection and maintenance procedures is essential for ensuring the safety of older homes with this type of wiring. Remember that electrical work should always be performed by qualified professionals to minimize the risk of electrical shock and fire hazards. For example, NEC Table 310.15b16 provides ampacity ratings for conductors based on their insulation type and temperature rating. It is crucial to select conductors with an ampacity that is suitable for the circuit load and the operating environment. Also, NEC Section 250.50 outlines the requirements for grounding electrode systems, including the types of electrodes that are permitted and the methods for connecting them. A properly installed and maintained grounding electrode system is essential for providing a low impedance path for fault current flow. Consider NEC Section 406.4d, which specifies the requirements for replacing receptacles in older homes. When replacing receptacles, it is important to ensure that they are properly grounded and that they meet current code requirements. The NEC provides comprehensive guidance on all aspects of electrical installations, and it is essential to consult the code to ensure compliance and safety. It's important to note that electrical codes and regulations can vary depending on the jurisdiction, so it's always best to consult with local authorities or a qualified electrician to determine the specific requirements for a particular location. The goal of electrical inspections and maintenance is to identify and correct any potential hazards before they can cause harm. By taking a proactive approach to electrical safety, homeowners can protect themselves and their families from electrical shock, fire, and other electrical hazards. While the focus here is on copper-clad aluminum wiring, it is also important to be aware of other potential electrical hazards in older homes, such as knob and tube wiring, ungrounded receptacles, and undersized service panels. These hazards should also be addressed to ensure the overall safety of the electrical system. A comprehensive electrical inspection should include a visual examination of all accessible wiring, a testing of all receptacles and switches, and a measurement of voltage and current levels. The inspector should also check for any signs of overheating, such as discoloration or melting of insulation. If any electrical hazards are identified, they should be corrected immediately by a qualified electrician. In some cases, it may be necessary to replace the entire electrical system to ensure safety and compliance with current codes. This is especially true in older homes where the wiring is outdated or damaged. Upgrading the electrical system can also improve energy efficiency and increase the value of the home. When upgrading the electrical system, it is important to select high-quality materials and components that are designed to last. This will help to ensure the long-term reliability and safety of the system. It is also important to hire a licensed and insured electrician who has experience working with older homes. An experienced electrician will be familiar with the unique challenges of working with older wiring systems and will be able to ensure that the upgrade is done safely and correctly. Remember that electrical safety is an ongoing process. It is important to regularly inspect and maintain the electrical system to ensure that it is functioning properly and that there are no potential hazards. By taking these steps, homeowners can protect themselves and their families from electrical shock, fire, and other electrical hazards. Firstly, remember to always turn off the power at the main breaker before working on any electrical circuit. Secondly, never overload circuits by plugging too many appliances into a single outlet. Thirdly, replace any damaged or frayed wiring immediately. Fourthly, install ground fault circuit interrupters in wet locations. Fifthly, test ground fault circuit interrupters monthly to ensure that they are functioning properly. Sixthly, keep electrical panels clean and free from obstructions. Seventhly, never use extension cords as a permanent wiring solution. Eighthly, have a qualified electrician inspect the electrical system regularly. Ninthly, install surge protection devices to protect electronic equipment from voltage surges. Tenthly, be aware of the signs of electrical problems such as flickering lights, burning smells, and sparking outlets. Copper-clad aluminum wire, while not currently used in new installations, poses specific considerations for older homes. Proper inspection, maintenance, and potential upgrades are crucial for mitigating risks and ensuring electrical safety. Consulting with a qualified electrician is always recommended for addressing electrical concerns in older homes. The National Electrical Code, or NEC, serves as the cornerstone for safe electrical installations in the United States. It is a comprehensive set of standards that covers all aspects of electrical wiring, equipment, and systems. The NEC is updated every 3 years to reflect the latest technological advancements and safety practices. Compliance with the NEC is essential for protecting people and property from electrical hazards. The NEC is organized into chapters, articles, and sections, each addressing a specific aspect of electrical installations. Chapter 1 covers general requirements such as definitions, wiring methods, and overcurrent protection. Chapter 2 covers wiring and protection, including conductor sizing, grounding, and bonding. Chapter 3 covers wiring methods and materials such as conduit, cables, and raceways. Chapter 4 covers equipment for general use, such as receptacles, switches, and lighting fixtures. Chapter 5 covers special occupancies such as hazardous locations, healthcare facilities, and swimming pools. Chapter 6 covers special equipment such as electric signs, elevators, and data processing systems. Chapter 7 covers special conditions such as emergency systems, fire alarm systems, and communication systems. Chapter 8 covers communications systems such as telephone, data, and cable television systems. Chapter 9 contains tables and examples to assist in applying the NEC requirements. The NEC is a complex and technical document, and it is essential to have a thorough understanding of its requirements before performing any electrical work. The NEC is not intended to be a substitute for proper training and experience. Electrical work should always be performed by qualified professionals who have the necessary skills and knowledge to ensure safety and compliance with the code. The NEC is a living document that is constantly evolving to meet the changing needs of the electrical industry. It is important to stay up to date on the latest revisions to the NEC to ensure that electrical installations are safe and compliant. The National Fire Protection Association, or NFPA, is the organization that develops and publishes the NEC. The NFPA offers a variety of resources to help people understand and apply the NEC, including training courses, publications, and online tools. The NEC is adopted by state and local jurisdictions throughout the United States. It is important to check with local authorities to determine the specific requirements for electrical installations in a particular area. Compliance with the NEC is not only a legal requirement, but it is also a moral obligation. Electrical safety is everyone's responsibility, and it is important to take steps to protect people and property from electrical hazards. The NEC provides a framework for safe electrical installations, and it is essential to follow its requirements to ensure the safety of electrical systems. The NEC is a valuable resource for anyone who works with electricity, and it is important to have a copy of the latest edition on hand. The NEC is available for purchase from the NFPA and other vendors.